In this video, we'll discuss scales and scale drawings. So before we talk about scale drawings and the math included with them, let's talk about a scale. So a scale in mathematics is very much like a ratio. It's a ratio comparing two different units. So like, for example, a pretty popular one you will see on like a map or a globe would be something to the effect of 1 inch is 10 miles. Now what this means is that for every inch on the map, it's 10 miles in reality. So if I was to go, say, 3 inches, well, that would be 30 miles in realisticness. So you can have these where they compare different units. That's one type of scale, and you can utilize these to do all kinds of different equations. They're useful in that we don't necessarily have to make something life-size. We also use these in terms of maybe not so much drawings, but if we're making replicas of 3D objects, like a model car or a model plane, a smaller scaled-down model where everything is kept in proportion. Meaning that if I shrink down something that measures 10 inches and I shrink it down to, or 10 miles and I shrink it down to 1 inch, well, when if I have something that's 20 miles, it has to be down to 2 inches. That ratio is maintained, the 1 inch being 10 miles. Now, another way you might see a scale would be with no units, and that would be like 1 to 8. So in this case, if they include no units, you can assume that these units are the same. So this would be like, on my scale drawing, 1 inch would be the same as 8 inches. The scale drawing would be an eighth of the size of whatever I'm looking at. So it's a different way of looking at a scale, but the same kind of concept applies. The only difference is we're not using different units, it'd be the same units. So let's consider an example. Let's say I have a blueprint for a house, and what is a pretty popular measure in blueprints is that 1 inch on the blueprint is 4 feet in reality. Or sometimes they'll write it as 1/4 of an inch is a foot, but they have the same meaning. So let's say hypothetically I have a room on my blueprint that's 5 inches by 6 inches, and I want to know how big in reality. Okay, so I want to know the size of this room, and there's a lot of ways you could do this. You could sit there and use the scale to your advantage and say, okay, well, if 1 inch is 4 feet, well, how many inches do I have in here? I have 5. Each one of those is 4 feet, so then this would have to be 20 feet. And a very similar logic for the 6 inch one. Well, there's 6 inches, each one is 4 feet, so 6 times 4, that's 24 feet. So I'd have a room that's 20 feet by 24 feet. Another way you can do this is you can set up a proportion. So if 1 inch is the same as 4 feet, and let's say I want to know about the 5 inch length. Well, I have to make sure I'm setting up my proportion the same. So if I'm looking at the top here, that's a blueprint measurement. So I have to use a blueprint measurement on the top of my other side. So in this case, the 5 inches, and the one I don't know, let's call it x, is right there. I can cross multiply, and this will get me x, because x times 1 is x, equals 4 times 5, which we know that to be 20. And in this case, my units would be feet. Now I could do something very similar with the 6 inches. I would set up the proportion very much the same way, and then I could go about it that way. Whatever method you choose is fine. They're both totally acceptable methods of doing it, and there's even more ways you could go about doing it, but that's the idea behind a scale drawing. So if something is to scale, it means that it is maintain its proportions. So we're dealing again with similar figures. It's basically just another name for that.